Let's look at the solutions of geometry bites. In a right angle triangle ABC, right angled at C, it is given that BC is equal to 8 centimeter, CA is equal to 6 centimeter. Okay. BCA, this is 8, this is 6. A line dividing the triangle ABC into two regions of equal area is perpendicular to AB at point X. Okay. Let's say this was the line perpendicular. The area here and here is equal. And the area will be how much? 8 into 6, 48. So this is area 12. This is also area 12. Okay. Perpendicular at the point X. Then length in centimeter of BX could be. Okay. The interesting thing here is the question says could be, does not say is, could be, because we could also have a shape like this. Let's say A, C, B. Now this is 6, this is 8, this is of course 10, this is of course 10. You could have a shape like this also where this point is X. So I have to take care of both these cases and then arrive at the answer. This is also 12, this is also 12. Let me first work with the second case. Okay. So if this is angle A, this is perpendicular as the question says, this is angle B. So let's see. I'm saying this is length K, this is length M. Look at triangle AXP. Look at triangle AXP and ACB. They are similar triangles because angle A is common and 90 degree, 90 degree. So opposite B, this will also be B now. Opposite B, I have K. Opposite B, I have 6. Opposite A, I have M. And opposite A, I have 8. Which means K by M is equal to 3 by 4. And we also know K into M. See, half into K into M is equal to 12. So K into M should be equal to 24. I already have the ratio. I already have K into M. Can I go? K is equal. How much do I need? I need K or I need M? I need K, no? No, I need 10 minus K. If I'm looking for BX, I'm looking for 10 minus K. Okay, so K value I finally need. M is equal to 4 by 3K. So K into 4 by 3K is equal to 24. Cancel, cancel. So K square is equal to 18 or K is equal to 3 root 2. So Bx in this case will be 10 minus 3 root 2. Sadly, none of the options correspond to this, which means this is not the case we had to work with. We had to work with this case. Extra smartness ends up making you work harder. So this is A, this is B, this is K again, this is M. Opposite to A, I have M. So M, opposite to A, I have 6. Opposite to B, I have K. Opposite to B, I will have 8. So K is equal to, no, I need M is equal to 3 by 4K. So now I can still replace it. This K into M is 24, is still valid. So 3K by 4 into K is equal to 24. Cancel, cancel 8. So K square is 32 or K will be equal to 4 root 2. I do have this option available. So answer to this question should be option C, but it is a hint. It says could be. Had it been the length of Bx is and there had been an option cannot be determined, that would be the right answer here. Next question, in the given figure, ABCD is a cyclic quadrilateral where AB is equal to 15 centimeter. Okay, this is 15. BC is 16 centimeter. This entire thing is 16. Cool. And angle ADC is 90. ADC is 90, which means AC is the diagonal. Is it compulsory? It is the diagonal. Yes, it has to be the diagonal. If it is subtending 90 degree, then this chord has to be 90 degree. Sorry, this chord has to be the diameter. If E is the midpoint of BC, okay, this is 8. Then which of the following is approximately the length of chord AF? See, if this is 90, this also has to be 90 because cyclic quadrilateral 8, 15, Pythagorean triplet. I know this to be 17. I know this to be 8. So now CE into EB has to be equal to AE into EF because they are intersecting chords. So 64 is equal to 17 into EF. So EF will be equal to 3 point something something. It is less, more than 3, less than 4. Okay. So AF is equal to AE plus EF. AE I know to be 17, EF I know to be 3 point something something. So overall my answer has to be 20 point something something. Why I'm working with 20 point something something is because the question says approximately. Answer has to be option A. Moving on. The perpendiculars AP, BQ, and CR are dropped from vertices ABC of a triangle. Vertices ABC of a triangle ABC on a line LM in the same plane as is shown in the below figure. The perpendiculars meet the line LM at points PQR respectively. Okay, all of them are 90 degree. Okay, fine. PQ is A. This is A. QR is B. AP is X. Oh, this entire length is Y. And CR is Z. Okay. Then the area of triangle ABC is. What I can see is I have lots of trapeziums here. Look at APQB. Can you see the area of that trapezium will be half into X plus Y into A. I got this trapezium. Now look at BQMC, half into Y plus Z into B. This much I will get. And now look at trapezium APMC. The area here will be half into X plus Z into A plus B. This gives me this area. This gives me this area. And this removes this area. So I will be left with the triangle only. So plus and minus is what I'm seeking. Okay. So now what will I be left with? Half I will take out because I'm only working with options. Half I can anyway remove, not a problem. I'm left with XA plus YA plus YB plus ZB minus XA minus XB minus ZA minus ZB. Okay. So XA gone, ZB gone. So if I take out A common, I'll be left with Y minus Z plus if I take out B common, I'll be left with Y minus X. And of course, I have my trusty half that I had removed from consideration. Y minus X I need and A. Okay, then option 1 should be the one that fulfills all criteria here. Next one, a triangle is divided into 5 parts as shown below as shown in the figure below. The figures mentioned inside each of the 5 triangles represent area of that triangle. Find the value of x1 plus x2. This is a fairly popular question. Look at this. Look at triangle BDC. C is the topmost point. So altitude for B, DFC and BFC, altitude is the same. It is just that their bases are different, because of which you are getting area 5 and area 10. So if this was Y, this base here will be 2Y. With that in mind, now look at triangle ABF and AFD. Altitude is the same. Base is in the ratio 1:2. So area should also be in the ratio 1:2. So x1 plus 8 by x2 should be equal to 2 by 1. Or x1 plus 8 should be equal to 2x2, or x1 should be equal to 2x2 minus 8. Okay, one relationship I have. Now if I can change color, yes. Now look at this. EF and FC. This color is no helpful. It is as good as black only. This one here. EF and FC. BEF and BFC. Altitude is the same. The base should be in the ratio 4W and 5W, so that you get area in the ratio 4:5. With that in mind, we will have x1 by x2 plus 5 is equal to 4 by 5. Now x1 I already know to be 2x2 minus 8. So let me replace that directly. 2x2 minus 8 by x2 plus 5 is equal to 4 by 5. Let me jump. I will get how much? 10x2 minus 40 is equal to 4x2 plus 20, or 6x2 is equal to 60, or x2 is equal to 10. So x2 I've got this region as 10, and x1 was equal to 20 minus 8, so it will be 12. So this region is 12. So when they're asking me what is the final value of x1 plus x2, answer should be option B, 22. Next one, within a square, R1 and R2 are radius of the circles with the centers O and O dash. Then R1 is to R2 is. Okay. This nonsense. Okay. This is a fairly popular setup. Just look at this. The point from here to here. This is R1. This is R1. So this length here should be R1 root 2. And now when you do it, do the same thing here. This is R1, this is R2, and now for this smaller space, this length here should be R2 root 2. So basically you have R1 root 2 is equal to R1 plus R2 plus R2 root 2. So R1 root 2 minus 1 is equal to R2 root 2 plus 1. Finally, they've asked me ratio of R1 to R2. Okay, R1 by R2 is equal to root 2 plus 1 by root 2 minus 1, which is present in option C. So that should be the answer. That will be all for this episode. Hopefully you learned something. Okay, bye.